Just as we can use equations to describe when two expressions are equal, we can describe other relationships between two expressions using inequality symbols. So we can use less than, print looks like this, handwritten looks like this. We can use less than to mean that the first expression is less than the second. We can use less than or equal, which is kind of what you get if you take a less than sign and cross it with an equals sign. Handwritten, we typically make the line parallel to the bottom of the less than sign because it's easier to draw that way. Less than or equal means the first expression might be less than the second one, or it might be the same. Then we have greater than, meaning the first expression represents a greater number than the second. Greater than or equal, meaning the first expression might be greater or it might be equal. And then our last inequality isn't really saying what order the numbers come in, just that they're not equal to each other. Now, the less than symbol and the greater than symbol, remembering which is which, some people use a trick where they say less than looks like the letter L, and then remembering what they mean. Well, I think that the easiest way to remember it is the big end of the symbol goes toward the bigger number. The small end of the symbol goes toward the smaller number. Okay, so just like equations, the big place where inequalities become interesting is when they're describing something about an unknown number. And in those cases, just like equations, we'll typically want to solve an inequality. So what does that mean? So again, an inequality is just describing a relationship using one of these symbols. And then we have definitions of a solution, values that make the inequality true, the solution set, the set of all possible solutions, equivalent inequalities, inequalities that have the same solution set, and solving an inequality, meaning to find its solution set. And since inequalities typically have a bunch of solutions, it's important to remember that our goal is to find the entire solution set and not just one solution. So, like equations, we'll use properties of inequality to get equivalent inequalities in order to solve an inequality. Now, just for visual ease, I'm showing these properties here for just less than. You can get the same properties for greater than, for less than or equal to, for greater than or equal to, just by replacing the appropriate symbol. So when we're talking about inequalities, there is a complication with specifically the multiplicative property. With equations, remember, we could multiply by any number that wasn't zero and get an equivalent equation. With inequalities, if we multiply by a positive number, we get an equivalent inequality that comes in the same order. But if we multiply by a negative number, that reverses the order. Think -1 is less than 1, right? Because anything negative is less than anything positive. Multiply by 5, and we have -5 is less than 5. But -1 is less than 1. Multiply by -5, +5 is greater than -5. So when we multiply by something negative, that reverses the order. Now, there are no complications like this with the additive property. The additive property, we can add anything we want to both sides of an inequality. And we can just think that shifts things back and forth. We always keep the order the same with the additive property. The other thing that reverses the order of an inequality is if we want to reverse the order in which we wrote our expressions. So if x is less than y, that means the same as y is greater than x. Now, with equations, the order doesn't matter, right? We can just swap the order. With inequalities, the order does matter. If we swap the order, that reverses the sign. And just like with equations, the big time we want to do this is if we've just solved an inequality and we ended up with our variable on the right. We like to write it with the variable on the left, which we can do. It just swaps the direction of the sign.